All right, here's the story problem from, I think it was example 9 that we didn't have time to do in class, so I just wanted to do it here. But basically the gist of this is you have something floating out here in air above the earth, and then what they're really asking for here is they really want to know the length or the arc length right there, because it's something is floating in the eye. I think in this example it's like Sputnik or something, and they want to know how much distance on the earth, how many people, I guess, lengthwise on the earth, in what mile range could actually see it in the sky, that kind of thing. So the main thing you have to think of here is that, first of all, you need to find the angle. And the reason is because for arc length, you either need a percent of circumference or you need to use the Radian formula. Either way, you're going to need to know an angle. Now, I drew I don't know if you can see it, but a little dashed line down here. All right, and so we have an angle on each side. I'll call that alpha, but the whole angle would be double alpha. All right, and I drew in some tangent lines. And if you're not sure what a tangent line is, you might want to look that up. But they, from a point to a circle, a tangent line is always at a right angle. And so I have a little triangle in here. I'm going to draw it out for you. So this little angle here, not both of them together, this one, is going to be my alpha. This distance right here, I don't know, and I really don't care about. This is a radius of the Earth, so that one I actually know. And this here is a radius up to that point, but then I'm adding another 14 miles because it's floating above the Earth's surface. So if I add that, so it's that plus that 14 miles right there. Now, in trig right now, we're only doing right angles, so that kind of limits us. And we don't really know a lot, but we do know SOHCAHTOA. So with this story problem, notice that you actually know the hypotenuse, so tangent's not going to be useful to us. So between sine and cosine, I don't know the opposite. This side over here, I don't know, I don't care about. So sine isn't going to be anything we care about either. So cosine of alpha is, let's see, adjacent, which would be this, over the hypotenuse, which is this. And again, that's just the radius and adding that extra 14. All right. So cosine of alpha is a ratio, right? This spits out a ratio. And again, if you want to convert that to a decimal, you can fill in the blank to that. But what I want is the angle. So whether you convert it to a decimal or not, I'm going to inverse that answer. So I'm going to just go ahead and leave mine in fractional form. And so I'm going to get an answer for that. And then I'm going to hit inverse cosine, or inverse cosine that ratio. And what that's going to spit out is an angle, which is what I want. So in this case, it spits out, oopsie, sorry about that. It spits out approximately, and I'm going to round to the nearest tenth, so it spits out approximately 4.8 degrees. If you wanted to be precise, you would use that entire number. So you would not round, but we're not worried about that in this example. All right, so then next of all, we want to find arc length. Now remember, our angle is the big angle, which is actually twice that. So about 9.6 degrees. Okay. And again, it's not going to be perfect just because I rounded. All right, so then for me, I like to do percent of circumference to do arc length. Let me push that back. Sorry, just a second. It might not let me. There we go. All right, sorry about that. All right, so I like to do a percent of circumference. So I would do, let me switch colors and get it not so thick. So I would do 9.6 degrees out of 360 degrees to get my percent. Circumference is either pi d or twice the radius. All right, and I just enter that in my calculator. Other people like the Radian formula, which is totally fine. R times theta, you know your radius, 3950. And then just make sure that's your angle in radians. You have some options. You could either take this one and convert it to radians by multiplying by, what would that be, pi over 180. Otherwise, way back on this step, when you hit inverse cosine, you could have made sure your calculator was set on radians and got an approximation on radians, and then again come down here and double the radians, and you would have got that answer. So however you wanted to do that, that's fine. I prefer this method. So if I type that in, I get approximately 661.8 miles. Now again, if you want a more exact answer, then at this step, I would use the entire degree. I would double the entire degree, and I would put that entire answer divided by 360 and do that. And I think it ends up in the, I can't remember if it's 664 or in that range, 663, I can't remember. But I did it similar to what your book did, so it would match. But again, that's how you find the angle, and then you use the angle to find the arc length.